plug in 0. When you plug in 0 for x to this parent function, you have the square root of 0, and the square root of 0 is 0. So you still have the point 0, 0. Okay, and this tends to happen with all of our functions. And my thing's like way not lined up. Look. Okay, 0, 0. Now, I can plug in, well, there are some numbers I can't plug in and get real numbers that I can plot on the graph. What can I not go and plug in right now for x? Negative numbers. We know how to deal with them and that we could get an imaginary part and have a complex number and all of this, but we can't graph those points on this real axis. So then I'm going to go ahead and only plug in positive numbers, but I want to be smart about what I choose to plug in. For example, choosing 1 is a good choice, okay? So the square root of 1 would be 1. So I plug in 1 and I get 1. So I have the point 1, 1. Now, do I want to plug in 2? No. So it's not that it doesn't have an answer. I could type in square root of 2 on the calculator, but it's going to be some irrational, never-ending number that's not really going to help me plot an accurate point on my graph. What is probably the next number I want to plug in? 4. Okay? So, because the square root of 4 is 2. So I'm going to plot a point at 4, 2. And then what would be the next number we'd want to plug in? 9. Okay? And I would have a point at 9, 3. My board's very much not lined up, so it's like playing a guessing game about where it's going to write. All right, so this is our square root function, meaning it's starting here and traveling through these points, okay, and making a curve like this. So it is growing, but like the cubic was like shooting up really fast, and the quadratic goes up pretty fast. This graph is going up as we plug in larger x values, but so slowly, right? What number would we have to plug in for x to finally reach 4? 16. What number would you have to plug in for x to finally reach 10 on the y-axis? 100. So it's going to grow really slow. You're not going to get up to 10 until you've gone out 100. Okay? So this is the basic shape of our square root function. And then if you want to make some notes of perfect squares so that you realize what we plugged in, okay, like 1, 4, 9, 16, that those are the numbers you'd want to work with your parent function to get the graph. The parent function is important. Okay, you're going to want to look at this when you do your homework because you're going to do problems just like you did on the last homework. But instead of having stuff inside of something cubed, all of that stuff that was inside of a cube is going to be underneath a radical. And you're going to start with this, and then you're going to do the same things. Oh, I'm going to shift it left and down. I'm going to reflect it this way. I'm going to horizontally stretch it, vertically compress it, or whatever the case may be. Okay? All right. So a couple important things about the parent function that we want to notice. Okay, so you guys look at your parent function. You have it in front of you. Where was the vertex of our graph? 0, 0. Okay. And yeah, the graph doesn't turn around at that point, but we're kind of using that starting point that sits on both the axes that wouldn't get reflected, okay, and wouldn't get stretched and compressed. That's kind of our vertex. Right? What is the domain of this function? All the real numbers? You guys told me only positive numbers, right? You guys told me I wasn't allowed to plug in negative ones if I wanted real answers. So the x values that we plugged in had to be greater than or equal to 0. What about the range of the function? So look at your picture and concentrate on the y values. Does it hit a maximum? Does it hit a minimum? What does that mean? All the y values on your graph are what? So we look back, right? Is there a maximum that you're going to reach? No, it can keep climbing forever. It takes a long time, but it can, right? Is there a minimum that you reach? Yeah, it doesn't go below this point. So that means every point that we plot for this graph, when we write down the ordered pairs, the y value is going to have to be a number that is greater than or equal to 0. Okay? All right, what about x-intercepts? Where does your parent function hit the x-axis? 0, 0. Now, is it possible for this graph to have more than one x-intercept? No, because even if you shift it down, it'll cross the x-axis eventually, right? But it won't turn back around and go the other way. Is it possible for it to have no x-intercepts? Yeah, right? If you move that parent function up so that it doesn't start on the x-axis and keeps climbing, okay? Or if you reflected it and it went downward instead of upward. All right, what about the y-intercepts? 0, 0. Is it possible for this graph to have more than one y-intercept? No, right? We can move it over so it hits at a different place, okay, or up and down so that it's at a different place, but it won't turn around and go back to the y-axis again. Is it possible to have no y-intercepts? Yeah, we could move it over so that, so is it possible for a graph of a square root to have no x-intercepts and no y-intercepts? Yeah, we could totally put that shape in a place where it will never cross the x or the y-axis. So a little bit different than some of the things that we looked at before just because of its shape. Okay? So we're going to walk through one example with all of the transformations. Okay. So here's the problem. We're trying to graph all of the transformations, and we're going to do this one step by step. Okay? So the parent function, because it's underneath a radical, is the square root function that we just talked about. Okay, so that's the parent function. So I would plot the points I know. And again, just keep this paper out when you're doing your homework so you have the picture of the parent function so you have a starting point. All right, so there's my parent function, just like we graphed. 0, 0, 1, 1, 4, 2, 9, 3. Okay? Now, before I start doing different transformations to this function, I need to recognize what the transformations are. So I need to be able to see them in the equation. Most of the stuff I can see clearly here. The only thing I would be concerned about is this 1/2 x plus 3. Okay? So what I should do in this case is underneath that radical, I need to factor the 1/2 out of the other terms that are in there. What's going to be left in that set of parentheses after a 1/2 is factored out? What's the first term going to be? X. Okay, that's not so bad. Oh, my pen's not lined up, so we see how it goes. Okay, plus, yeah, I know. I've got to recalibrate. Okay, so we have x plus. So it was a 3 sitting here, but you've taken out of 1/2. So you took that 3, you divided it by 1/2. What number would be there? Not divided it by 2, divided it by 1/2. So there was a 3. I divided it by 1/2. Good. So it should be 6. And it should make sense when I'm done. Because does 1/2 times 6 equal 3, what I had before? Yeah. Okay. All right, now I can see all of the transformations that I need to do. So what do you guys want to do first? You guys can pick. It doesn't matter the order. The only thing that does matter is that once you translate, okay, and you've moved your vertex, if you do any reflections, stretches, or compressions, you now need to do them around the vertex, okay? All right. Somebody point out a transformation for me, and then we will perform that. So when you look here and you see a negative, a 3, a 1/2, a 6, a 1, tell me something that means. John. Okay, so because of the plus 6 right here, we need to move the whole graph left 6. All right? So we're going to go ahead and do that. So the first transformation we're going to do is we're going to translate, which is like shifting left 6. This is nothing new. So this is what I was talking about before. I'm not saying we're not learning a new function. We are. This is a shape we haven't done before. But before, when it said x plus 6 inside the function, we knew that was a translation left 6, and we moved the whole function left 6. We're doing the same exact thing here. None of that work is going to change. You're just doing it with a different shape. Okay? Oops. So there's my whole graph moved left 6. Is this okay with everybody? No, you're fine. All right. Next transformation that you guys want to perform. Somebody else, raise your hand, give me a transformation to do. Liam? Okay. So we'll go ahead and go down 1. So the left 6 was because of this plus 6. The down 1's because of this minus 1 here. So the next thing I'm going to do is this vertical translation. So I'm going to translate my graph or shift my graph down 1. Okay. So I'm going to take this whole thing and move it down 1. So my vertex should now sit at -6, -1. And that's the final resting place of my vertex. Remember, only translations move our vertex. All stretches, compressions, and reflections will now be done around that point. So here's my graph after I've translated down 1. Okay, so I've taken care of all the translations. So things that would be left for me to be would be any sort of reflections, stretches, or compressions. Okay, John? Good, a vertical reflection. So remember, all the horizontal stuff is captured inside the function. So in this function, it's all the stuff that's underneath the radical. Anything that's outside of the radical is all vertical stuff. So this negative that's out here with the 3, that's going to be a vertical reflection, which means it's going to flip your points that are above the vertex so that they are below the vertex. Okay? So I'm going to go to the next graph to graph that step. I'm going to still put my vertex at -6, -1. It doesn't move now that the translations are done. So I'm going to go ahead and put my vertex at -6, -1. That point's not moving. And now I'm going to go ahead and do the vertical reflection. Okay. So remember, look at your previous graph. There was a point that was 1 away from this vertex point and 1 above it. We're dealing only with the vertical. So we're still going to go 1 away from the point, but rather than plotting the next point 1 above it, we're going to plot it 1 below it. That's a vertical reflection. It was above, and now it's below the same amount of measurement. So that point's going to end up here. Okay. Then there was a point that was 4 away from the vertex horizontally and was 2 above it. We're going to now reflect that point. So rather than being above the vertex 2 units, it's going to be below the vertex 2 units. Okay. So it's going to be here. And then we had a point that was 9 away from the vertex and 3 above. And again, it's going to end up 3 below. So we had a point here, okay, 9 units away from the vertex and 3 above it. And we're just going to change it so that it's 3 below the vertex instead. So now our graph goes this way instead. So now it's decreasing slowly as it's traveling. So it's like we just took it and flipped it over the vertex. Okay. Is this okay with everybody? So same things as before. Translations move your vertex point. You know the structure of the parent function, and then you just move points around the parent function by reflecting them, stretching, or compressing a certain distance in a certain direction, but it's just a new shape. All right, what else do we have to do? Oops, wrong way. Okay, so we've done the +6, which was left 6, -1 was down 1. We've worked with this negative from the 3 that was a vertical reflection. So we still have the number 3 and the number 1/2 to deal with. So somebody tell me what we can do with one of those. John knows, but I know he knows. Ben? Vertical, sorry, say again? The horizontal stretch? Yeah, absolutely. Okay, so where is he looking when he's saying horizontally stretch? Good, he's looking at the 1/2. Now you guys might think, oh, 1/2 small, it compresses things, but what are we really going to multiply by when we pull that 1/2 out? 2, because it's the horizontal one, so we're using the reciprocal, right? So when I go back to my graph, here, this is going to be horizontal because it was inside the radical. Then I look at the number. It said 1/2, so in my head I'm thinking that means I'm multiplying things by 2 over 1, which is 2. When I times things by 2, it's going to make them bigger, so that makes me write down the word stretch. And that means I'm going to make horizontal distances, how far things are from the vertex point horizontally, bigger by timesing them by 2. Okay? So again, my vertex isn't going to change. It's going to sit at -6, -1. So go ahead and plot that point. It's the points around it that are going to change, and right now I'm only changing their horizontal distance. So see how this point right here, it's 1 below the vertex, right? That's not going to change. I'm still going to plot a point on this side of the vertex that's 1 below it. The difference is going to be how far it is from the point horizontally, right? So currently, this point that I've circled right here, how far is it from the vertex horizontally? 1 unit. It goes 1 to the right from the vertex. But I'm going to take that 1, I'm going to times it by 2, and my new distance is going to be 2. So I'm now going to plot that point 2 units horizontally from the vertex before I plot it 1 below. So I'm going to go over 2 before I plot that point that's 1 below. Okay, next point to look at, this guy right here. We're still going to plot a point that's 2 below the vertex. We're not changing anything vertical right now. Okay, but we are changing the horizontal. Mikey? Exactly. So do you guys know where Mikey's getting that 8 horizontal? This point that I circled, how far is it horizontally from the vertex point? 4. Okay? But again, I'm taking the distance that's in my parent function, the normal distance, and I'm adjusting it by whatever the stretch or compression number is. So 4 times 2 is 8. The horizontal distance to this point now has to be 8 away from the vertex before I'm allowed to drop 2 below. Okay? So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8 before I plot that point that's 2 units below. So when doing your stretches and compressions, if it's horizontal, you're looking just at the horizontal distance from the vertex, you're multiplying it by the number, and you're replotting it that new distance away. Okay, but keeping the vertical the same. And when it's the vertical, we'll do the other way around. We'll keep the horizontal the same, and we'll just adjust the vertical. Okay? All right, so this third point over here that we had plotted from the vertex, how far horizontally is that from the vertex? 9 points, or 9 units. So 9 times 2 would be 18. So that's going to be a little bit outside what I have room to plot on my graph, maybe not. But if you want, you could go 18 units, okay, from the vertex horizontally to go 3 units below. And do you guys see why it's important to not just say, like, oh, horizontal stretches this, vertical stretches this, and just use it like slope, like, oh, I'll just keep going up 3 over 2, up 3 over 2. You're going to draw lines. These things aren't lines. That's why you have to use their original distances of how they were originally built and then just adjust those. Okay. All right, what is our final transformation that needs to happen? Good, a vertical stretch by 3, okay? The only thing we haven't used is this 3 out here. So unlike the horizontal, the vertical numbers are very like, here's the number and here's actually what you do. So it says 3 and we actually multiply by 3. So I'm going to write vertical because it was outside of the square root. And because it's vertical, I know I used the number exactly as it was. So it was 3, so I'm using 3. When I times stuff by 3, am I making them bigger or smaller? Bigger. So this would be called a vertical stretch. And again, our vertex point is only affected by translation, so I'm going to start at that same place, -6, -1. Okay. All right, so now I'm going to do almost exactly what I just did, except for I'm going to focus all on the vertical distances now. So this point right here, it's 2 units horizontally from the vertex. I'm not going to change that. So I'm still going to come to my new graph and plot some point 2 units away from the vertex and some amount of units down. But what I'm going to adjust is how many units it is down. How many units right now is this point down from the vertex point? 1. okay? But I'm going to take the 1 and I'm going to times it by 3 because that's my stretch factor, and I'm going to get 3. So this point now needs to be 3 units below the vertex rather than 1. Okay? So not changing the horizontal, so still 2 this way, but then 3 below. Okay, next point that's over here, okay, it's 8 units away from the vertex horizontally. I'm not going to change that. So I'm still going to go on my new graph, and I'm going to go 8 units away horizontally and some amount down. But the some amount down is the part that's going to change. This point right here is currently how far below our vertex? 2 units, okay? So I'm going to take that 2, I'm going to times it by 3, and I'm now going to have 6. Okay, so I need to plot this point so that it's 6 units below the vertex. So I'm going to go over that 8 units from the vertex, but now I'm going to go 6 below. So notice that vertically stretched our graph and made it start growing a little bit faster. Okay, it's still not like a cubic. It doesn't keep shooting down. It still curves and kind of levels off. But the stretch helps it go a little bit faster. Okay? Is this okay with everybody, how we walked through the transformations? Questions? Yeah, I'm so. We do them separately, but they've both been accounted for. Yeah, so notice that when we did the vertical stretch, we did it to the graph that we got after we had already done the horizontal stretch. So we kept the measurements from the horizontal stretch the same and then stretched the vertical distance as well. Okay, so as long as you don't go back to, like, if I had come back here and then did the vertical stretch, then I wouldn't have the right graph because it would have left this part out. But as long as I do this after I've already done this, it's like, okay, I stretched everything horizontally. All right, now I'm going to come and stretch it vertically, and I'm taking care of each of them. Okay, so they're both in there. You have to have done them both. Is that okay? No, this one has the horizontal stretch. So remember, the horizontal stretch is the change from here to here. So originally our graph, to plot a point 1 below, we went 1 over to go 1 below. So the horizontal stretch says instead of 1 over to plot that point, you should go 2 over. This graph still has this. It's still 2 over before I plot the point that goes below. Okay. What's that? I didn't put the last one because it had to be 18 units away from this one, and it was going to go off my graph a little bit. Oh, okay. Okay. Is that all right? So are we okay with this? So this is basically, we get to review a lot the stuff you might have been struggling with transformation. So if you didn't learn it, it's like, oh, relearn it now, relearn it now, relearn it now. The only difference is a new shape each time that we're going to do it. Okay? So keep in mind what our shapes looked like for cubic stuff, which had, something to the 3rd power. It was kind of like this. Now we did square root stuff, which means you had the radical. It looked like this. Okay. And we're going to do one other one today, again, so it's like we're getting review, but the shapes. But when you're doing your homework, each homework assignment practice is one. Just keep the thing in front of you, but all the transformations and everything you're doing is the same, just to a different shape. Okay, that's why we're doing them together. All right, so let's look at one other function, so the cube root function. Okay. And this is the last new function that we have to learn. So the only other thing we have to learn are piecewise functions, which you guys already learned how to do piecewise functions. But when you learned piecewise functions, you only used pieces that were shaped like lines. And now we have lots of other things. So we could have a line and then a parabola and then something else. So we're going to practice that a little bit after this. But you have all the functions you need after this, okay? So the cube root is going to be just that, a cube root of x. Okay. So remember how with the square root we were really careful to plug in which numbers we want to plug in? With the cube root, it's just as bad. Okay. So I could choose 0, and if I plug in 0, what's the cube root of 0? 0. Okay, so I'd plot 0, 0. And then is 1 okay to plug in? What's the cube root of 1? Yeah, it works okay, right? So 1, we get 1. Is 2 something we want to plug in? No. What would be the next number that I would even want to plug in? 8, because the cube root of 8 would be 2. So I only want to plug in these numbers that are perfect cubes. So I would have to go all the way to 8. It doesn't mean you can't plug something in and get something, but it's going to be some crazy square root decimal thing that you can't really plot accurately. So at 8, I would get 2. If I were going to keep going, what would be the next number I'd want to plug in? 27 to get 3. So it would take me a really long time. Now, so this looks a lot like the square root function, right? Except for that it just takes a little longer to reach 2. Just like the cubic, this part of it, okay, kind of looks a lot like a quadratic, right? It just grows a little bit faster. Okay. Now, with the square root, we said we couldn't plug in negatives. Can we plug negatives into the cube root? Yeah, what's the cube root of negative 1? Negative 1, because negative 1 times negative 1 times negative 1 would still make negative 1. So here we can plug in negatives. What would be the next negative number that I'd want to plug in to be able to easily calculate the cube root? Negative 8, because what will the cube root of negative 8 be? What's the cube root of 8? 2. So the cube root of negative 8 is going to be negative 2. So 1, 2, 3, 4, 5, 6, 7, 8. Okay? And so this is what my cube root graph looks like. Now, a mistake that students often make, Lord. They mess up the cube root and the cubic, okay? So what you have to kind of keep in mind is when you're cubing things, they're growing really fast. So it's shooting up and it's shooting down. When you're cube rooting things, you are like diminishing their value a lot. So they don't really shoot anywhere. They just grow very, very slowly, okay? All right? Okay, so again, when you're doing your homework, am I saying have these memorized yet or anything like that? No. Have the cubic, the square root, the cube root in front of you so you have the starting point every time. I want to know you can do the transformations to the graph. Okay? All right, so that's what we're going to practice after we write down some of these things. Okay, so the vertex here was at 0, 0 still. What's the domain of the cube root function? All real numbers. Okay. So it was weird with the square root. We had to say, oh, you can only plug in positive things. So we said greater than or equal to 0. But here we got everything. What about the range? All real numbers. It grows really slow. But it's not only growing in one direction like the square root. It's growing in the other direction, too. So it will go both up and down. So our range will still be all real numbers. And for the parent function, where is our x-intercept and our y-intercept? 0, 0. And for these ones, even though they're growing really slow, they are always growing up and down. So you're always going to have an x-intercept and you're always going to have a y-intercept. It would eventually hit both of the axes. Okay? If you need to write anything down here, you can. So we're going to go through one more problem like we just went through. Again, this should basically be like if you're like, oh, I don't get the reflections, you should really pay attention in the reflection step. We're not doing new things. We're just starting with a new shape. All right, so here's our function. Oh, it's almost the same. Okay. So how do I know to start with this cube root shape instead of the square root shape? Well, I have a cube root in my problem. Okay. So I know that my ending graph shape should look something like this. And again, I need to rewrite it so that I see all of the transformations. So I need to factor the 1/2 out of what's inside of the radical. That doesn't mean the 1/2 gets outside the radical. It just means what does it look like when you take it out of here. So the first term is x, and we already talked about if it says +3, how to factor a 1/2 out of that, and that we would have +6. Okay. Yes, you would factor the negative out with the 1/2, and then it would change the sign of the second one. And then it would be a horizontal reflection instead of a vertical one. Okay. All right, so again, we're starting with the parent function. So first step, just go right down, copy down the parent function that we just created for y equals the cube root of x. Okay? So I just copied my parent function. I had my point, my vertex point at 0, 0. And 1 to the right was 1 above, and 8 to the right was 2 above. 1 to the left was 1 below, and 8 to the right was 2 below, okay, based on how we saw the cube root function work. All right, somebody give me a transformation that we want to do. Left 3. The 3 is not going to go left because the 3 is outside the radical. So what's the 3 going to do? Down. Okay, so we'll go ahead and do the left 6 and then the down 3. So we'll do our translations again first, which is totally fine. But then once we are done with those, our vertex is in the right place and won't move again. We'll just reflect and stretch and compress all around it. Okay? So we'll go ahead and go translate left 6. So the vertex moves to the left 6. Now, for those of you who had bugged last time when all of a sudden a point wasn't on our graph, it's not that I'm ignoring that there's another point. 8 to the left of the vertex here would be 2 below it, but it's just off my graph, so I didn't plot it. Okay? So this is my vertex right here that moved left 6. I had space to plot both of the points that were to the right of it, but I didn't have enough space to plot the second point that's to the left of it, and that's okay. So the next translation I'm going to do is the translation that goes down 3. So this is going to put my vertex. It's already moved 6 to the left, and now I'm going to move it down 3 in addition to that. So my vertex should show up at -6, -3. And then I'm still going to structure the points around that vertex the same, meaning 1 space to the right of that vertex, there was a point 1 above it. And 8 spaces to the right of the vertex, there was a point 2 above it. And 1 space to the left of the vertex, there was a point 1 below it. And then 8 spaces to the left of the vertex, there would be a point 2 below it. That's off my graph. If it's not off of yours, you can fit it and plot it, and that's fine. So we're okay? All we've done is taken the shape of the cubic function, and we shifted it left 6 and down 3, so our vertex is now at its final spot. All right, what's the next transformation that we need to do? So we've done all of our translating, moving things around. Now we're looking for reflections, stretches, or compressions. Yeah. Sure. Okay, so the negative is going to cause a reflection. What kind of reflection? Would we call this a vertical reflection or a horizontal one? Vertical because it's outside the cube root or over the x-axis. So we're going to go ahead and do this vertical reflection. Again, this doesn't affect our vertex point, and we've already determined our vertex point is at this -6, -3 location. So I'm going to keep that point there. But what I'm going to do is where points used to be above that vertex, I'm going to move them below. So it used to be that 1 to the right, there was a point 1 above this vertex. I now want to go 1 to the right, and I want to plot that point that was 1 above. I want it to be 1 below the vertex. So it's going to be over here. The vertex is at -6, -3. Then there was a point that when we went 8 away from the vertex, it was 2 above. I now, when I go 8 away from the vertex, want to plot that point so that it's 2 below, so that it's been reflected below the vertex rather than above. Okay? So 1 away should be 1 below the vertex, and 8 units away should be 2 below the vertex. Okay, it also used to be that 1 to the left, there was a point 1 below. So I now want, when I go 1 to the left, to have that point to be 1 above the vertex. And it used to be 8 to the left had a point 2 units below, so 8 to the left would have one 2 above. But again, that's off my graph, so I'm not going to draw that one this time. So there's our reflection. Okay, looking back, what do we have to do besides the reflection? We haven't dealt with the 2 or the 1/2. Somebody raise your hand and tell us what to do with one of those things. Huh? Good. Okay, so this 1/2 in here is the horizontal change because it's inside the radical. And remember, the horizontal stuff is crazy, so I see the number 1/2. It's inside, so I know to automatically write horizontal. And then I know to use the reciprocal of it. So instead of multiplying by 1/2, I'm multiplying by 2. So this is a horizontal stretch. So my vertex is going to stay at -6, -3. I'm only changing horizontal distances. So this is 1 unit below vertically. Okay, that's going to stay. There's going to be a point that's to the right of the vertex that goes 1 unit below. But how far to the right is the question. Right now, this point down here is 1 unit to the right of the vertex. I'm going to take that measurement of 1 and I'm going to times it by 2, and I now want to use a measurement of 2 instead. So to get to the point that goes 1 below the vertex, I'm going to have to go 2 to the right and then 1 below because I'm stretching it horizontally. Okay. What about this second point out here? How far was it horizontally from the vertex? 8 units. Okay? So 8 units over to go 2 units below. Well, I'm taking that 8, because that's the horizontal measurement, stretching it by 2, so I'm going to have to go 16 units over before I can drop a point 2 below. So barely makes it. Okay? And this point right here that's above the vertex, it was 1 to the left and then a 1 above. I already did 1 times 2 and know that it changes to 2, so I'm going to go 2 to the left before I go 1 above. So I've done the horizontal stretch, and what was the last change that we had to do on the graph? The vertical stretch. There was a 2 out in front of the cube root as well. Okay? So when it's a vertical change, we just take the number as it is. Vertical because it was outside of the function. And so we're going to do a vertical stretch. So vertex is still going to stay at -6, -3. So start by plotting that point. We've already done the horizontal stuff. So from our vertex, we're still going to go 2 to the right to get this point that's 1 below, but it's not going to be 1 below anymore. Okay, because right now it's 1 below, but I want to times that by 2. So I want to replot the point so that it's 2 below. So I'm going to go over 2, and now this point, instead of being 1 below, is going to be 2 below. Okay? And so that same thing's going to happen with the point that's 2 to the left and 1 above. It will now be 2 to the left and 2 above. What's going to be the change for this point that's out here? So this point from the vertex is currently 16 units away horizontally and then 2 units below. Coletta? Good. Notice she didn't say anything about the 16 units because that's going to stay. So we're still going to go 16 units away horizontally, but rather than going 2 units below, it's going to go 4 units below because 2 times 2 is 4, and 2 was our vertical stretch factor. Okay? So now my graph is going to fit these points. One note. Notice that even though I stretched it out vertically and it got a little bit steeper, do these arrows at the ends shoot up and down? No, they shoot more horizontally because the cube root is so slow, right? If you shoot them up and down, I'm going to think that you're graphing a cubic. Do you understand the difference? Like if you curve this arrow at the end and make it go up, I'm going to think you think you're graphing this. Okay? So cube root arrows should be pretty flat towards the end because they're not growing fast. And cubics, when things are being cubed, should be shooting up and down. Okay? So is this okay with everybody? Same cycle over and over and over. New starting shape. Okay? So your homework.